and a half. Let's talk about React Router. What? What is React Router? Who knows how to read? You talk too much. All right, go for it.
A JavaScript package that allows
What's a JavaScript? What? Well, yes, what should be the first thing you say?
What is
Yeah, just start from the heading. That's all I'm saying.
what is React Router? A JavaScript package that allows our UI to stay in sync with our URL. It allows us to render specific components based on which routes match or don't match the current URL path.
True story. Anybody ever used another web framework that has routing in it? But yeah, what have you used?
Technically, it's not too much routing, but I use the API for Wikimedia. That's
Okay. Okay, cool. So routing in general, lots of frameworks have it. Basically keeps the UI in sync with the URL. Back in the very first day, we had the diagram of the laptop on the left, the big question mark on the right. We had a request going out and then a response coming back. So on a static web server, you just request something, it picks the file up and sends it right back to you. But we have written a single page app here. Index.html is the only actual HTML file we have. But it'd be really cool if we had other URLs we could visit. And no matter what, we would still get index.html back, but React would handle figuring out which components to show and hide. So we want to show and hide different components based on the URL without screwing up what happens with the web server. So that's what routing is for. Without actually changing pages, changing what we see on the screen. So to get started with React Router, as you might guess, you need to add React Router, specifically React Router DOM. Just like we have React DOM, we don't need to do this right this second, but there's React Native and stuff too. So React Router DOM is the package that we add. Yarn add would download it, put it in your node modules folder, and add it to your dependencies in package.json. So that's how you'd add it to a project. And then back on index.js, a file we haven't touched really ever, because it's already there for us when we use create React app. But remember that one call that we have to do if it weren't already there for us, where we replace that one DOM element with our component, with our app component. Well, now we just wrap the app component in router, and we have routing available to us. From there, we define one or more routes. And they look something like this. So React Router has a component built in called route. We can use it to define different routes. Each route consists of a path, optionally, and what component or what that route should point to. So in the first example, we see route path equals /widgets, component equals widgets. So that means when the URL matches /widgets, it will give us the component widgets. Now, that route also matches /widgets /57. That still matches because we didn't say exact. So in the second example, we see route exact path equals stuff. So if you throw that exact prop on there, it will not match, for example, /stuff /86. It has to be exactly /stuff. First example, because exact isn't there, it would match /widgets /something else. Second example would not. There's another difference between these two routes. The first one just says component equals and then the name of a component. The second one has a render prop. And it looks like its value is actually a render method. Got an arrow function there that returns some JSX. So two different ways you can do this. You can just tell it what component to put, or you can actually put a render prop in there and actually write a function right there. Can anyone guess why you might want to do it the second way? Yeah. To pass props in, right? If you just say component equals whatever, you can't pass any props. So yeah, in the second example, we could actually pass some props to that. Very good. So defining routes. So once we have routes, we need a way to actually link to those things. And there are two different link components included in React Router, link and navlink. So they have a prop called to instead of href like you would have in a traditional link. They do just render down to an ahref in the end. So you say link to and then the path to that route, or navlink to. The difference between the two, navlink adds an active class to the link that gets rendered if you're already on that page. Pretty common thing to do, have an active link or have an active class on a link if that's the page you're already on, so you can show the current link a little differently than others. You could highlight it differently, or if it's a tab, you don't show the bottom border or whatever. So that's the difference between link and navlink. Navlink will put an active class if you're already on that page. Let's talk about params. So here we see an example. Here's a component down here, user about, returns some JSX. Up above, we have my page, receives some props, returns some JSX, and it has a link to /about/Bob. And we see it define a route. The path to that route is /about/:name. That colon indicates a param. So that means it's a variable in the middle of the route. So /about/anything will match this route. And that should point us at the component user about, which you see down below. So that link, /about/Bob, that matches. That matches that route. So somehow from within the resulting page, we need to be able to find out that name was Bob. And this is how you do it. There are 3 props that get passed down when you end up at a component because of a route. Match, history, and location. Match, history, and location. So match contains, among other things, the params. So in this case, we ended up at user about through a route, but that route had a param in it called name. So if we need to find out what the value of that was, we can get to it through props, .match, .params, whatever the param was called, which in this case is name. So this will say this is a page about Bob, assuming you clicked that link to get to it. We'll see examples. So that's one of the 3 props that we get. History, location, and match. That's a match. That can show us params if we had any. Then there's history. Who knows how to read? Go for it.
History. History keeps track of all the user's navigation over time. It can be used to programmatically navigate without using links. There are many useful history methods. Push, go back, go forward, go in, and block.
Yeah, and there's more than that too. We're especially interested in things like push, go back, go forward. So this is based on the HTML5 history API that's built in to your web browser as of HTML5. This is what lets us actually mess with the browser history without really changing pages. That makes client-side routing possible. So history.push adds something new to the history, navigates to a new URL without actually changing the page. But it totally adds it to your browser's history. History.goBack does just what it sounds like. Does the same thing as the back button. Go forward, same thing as the forward button. Go parentheses in, whatever you pass in is in, it's going to go that many back. So you could go 2 things back in your history. As you might guess, there's a history.push, there's also a history.pop, which is an awful lot like the back button. So that briefly is React Router. We'll see some examples. Now let's talk about fetch. Yes, ladies and gentlemen, HTML still trying to make fetch happen. So who knows how to read? Go for it, Daniel.
Fetch. The Fetch API provides a JavaScript interface for accessing and manipulating parts of the HTTP pipeline, such as requests and responses. It also provides a tool for fetch that provides an easy, logical way to fetch resources asynchronously across the network.
Very good. Yes. So this gives us a way to talk to APIs really easily without using AJAX. So we can make additional HTTP requests without navigating to a new page and without replacing the whole page. Yeah.
I have a question. What's the difference between an API and a library?
I mean, some libraries have APIs, and you may get access to an API through a library. But a library would be a piece of code that you actually add. An API is the interface that you use to interact with something. So if you do add a library, that library is going to have an API that you talk to. But when I talk about an API in this context, I'm talking about like a third-party service that you talk to over HTTP. So API can kind of refer to a couple different things. It always means the same thing. But you can talk about the API of something, and that's just, you know, what methods it exposes, how you talk to it, what its public interface is. When I talk about an API like we're going to talk to with Fetch, I just mean like a third-party service that exposes an API for us to talk to over HTTP. Yeah, so I'm talking about a specific kind of API, like a REST API, if you've heard that. So yeah, Fetch makes it especially easy to talk to REST APIs. So here's an example. That should not say params at the beginning. I thought I finally corrected this. I didn't. That should say fetch again. So yeah, here's the actual fetch method and how it works. So fetch, give it a URL, and then that returns a promise, which we saw for the first time yesterday, I think. Because fetch happens in the background. It'll make this asynchronous call over HTTP, and then it'll just go ahead and run whatever the next line of JavaScript is. So if you want to do something with the result of that fetch, you're going to have to use .then or some other way to do asynchronous programming. But in this case, we could call .then and then give it an arrow function to say something that we want to do with the response. In this case, our API returns some JSON, so we can do this stuff. We'll see some examples. So let's give it a shot. Questions before we get started using it for real?